A perfect storm of winter weather is unfolding across America, and the science behind what we're seeing is absolutely fascinating. From blizzards in the Midwest to freezing rain in the Northeast to flooding in California, every single one of these events is connected to the same atmospheric pattern. Over 9,000 flights canceled, 3 people dead in California, hundreds of thousands without power. And this is just the beginning of a pattern that could dominate our weather for weeks. I'm going to take you on a deep educational journey through winter weather over the next 30 minutes. You're going to learn how to forecast weather yourself using simple observations. You'll understand the difference between weather and climate and why that matters. You'll discover why some storms produce snow while others produce ice. And you'll walk away with practical knowledge that makes you safer and smarter about winter weather. By minute 9, we'll explore atmospheric layers and temperature profiles. At minute 17, you'll learn to read clouds and predict precipitation. By minute 25, we'll cover cold weather physiology and health. Let me start with a fundamental question. What is weather? Weather is the state of the atmosphere at any given time and place. Temperature, humidity, air pressure, wind speed and direction, cloud cover, precipitation. These are all elements of weather. Weather changes constantly, sometimes from hour to hour. Climate, on the other hand, is the average weather conditions in a place over a long period, typically 30 years or more. Why does this distinction matter? Because when we talk about unusual weather patterns like what we're experiencing now, we're not making claims about climate change or long-term trends. We're observing that the current atmospheric configuration differs from average conditions. The jet stream is in an unusual position. Temperature gradients are stronger than normal. Storm tracks are more active than typical for late December. These are weather observations, pure and simple. Now, let's talk about what's driving this pattern. Everything in weather comes back to uneven heating of the Earth's surface. The equator receives more direct sunlight than the poles. This creates a temperature difference, and nature abhors imbalance. The atmosphere and oceans work constantly to redistribute heat from warm areas to cold areas. That redistribution is what creates wind, storms, and all weather phenomena. The jet stream is the primary mechanism for moving heat in the middle latitudes, where most Americans live. This narrow band of fast-flowing air 5 to 7 miles above the surface marks the boundary between cold polar air and warmer tropical air. When the temperature contrast is strong, the jet stream flows fast and relatively straight from west to east. When the temperature contrast weakens, the jet stream meanders north and south in large waves. Right now, we have what's called a split flow pattern. Instead of one main jet stream, we effectively have 2 branches. One dips south through California, pulling moisture from the Pacific. Another flows across the northern United States and southern Canada, creating a highway for storm systems to travel from the Rockies through the Great Lakes to the northeast. This split flow is why we're seeing major weather events on both coasts simultaneously. The storm currently impacting the Great Lakes and Northeast started as a weak low-pressure area over the Central Plains. Low pressure means the air is rising. As air rises, it cools. As it cools, water vapor condenses into clouds and precipitation. The stronger the upward motion, the heavier the precipitation. This low-pressure system intensified as it moved east, and here's why. Ahead of the low, warm, moist air from the Gulf of Mexico flowed northward. This is called the warm sector of the storm. Behind the low, cold air from Canada pushed southward. This is the cold sector. The boundary between these air masses is a front, specifically a cold front, where cold air is advancing, and a warm front where warm air is advancing. The low-pressure center sits at the point where these fronts meet, called the triple point. As the warm, moist air is forced to rise over the cold, dense air, rapid condensation occurs, clouds thicken, precipitation intensifies. At the same time, the temperature contrast creates a strong pressure gradient. Remember those isobar lines on weather maps? When they're packed together, winds are strong. This storm has extremely tight isobars, which is why we're seeing winds of 50 to 70 miles per hour. Friday night, this system brought heavy snow to the northeast. New York City's Central Park recorded 4.3 inches, the heaviest snow since January 2022. The month of December has now exceeded 7 inches total, something that hasn't happened in about 4 years. But here's the interesting part. Snow totals varied dramatically across the region. Bob Oravec from the National Weather Service noted snowfall ranging from 6 to 10 inches from Syracuse to Long Island and parts of Connecticut, while New York City itself saw only 2 to 4 inches. This variation teaches us something important about microclimates. Cities create their own weather. Urban heat islands, the concentration of buildings and pavement that absorb and retain heat, can raise temperatures 2 to 5 degrees Fahrenheit above surrounding areas. Why does 2 to 5 degrees matter so much? Because winter precipitation types are incredibly sensitive to temperature. Let me explain the different types and how they form, because this knowledge will help you understand tonight's forecast. Snow forms when temperatures are below freezing throughout the entire atmospheric column from cloud to ground. Water vapor in clouds condenses directly into ice crystals. These crystals grow as they collide with supercooled water droplets. When they become heavy enough, they fall. If temperatures remain below freezing all the way to the surface, you get snow. Sleet forms when there's a warm layer aloft. Snow falls from clouds, melts into rain as it passes through the warm layer, then refreezes into ice pellets as it falls through cold air near the surface. You can hear sleet hitting the ground with a distinct pinging sound. It bounces. Sleet creates slippery conditions, but not as dangerous as freezing rain. Freezing rain is the most hazardous precipitation type. Like sleet, it starts as snow that melts into rain in a warm layer aloft. But the difference is the cold layer near the surface is thinner or weaker. The raindrops don't have time to refreeze into ice pellets. Instead, they remain liquid but become supercooled, meaning they're below 32 degrees but still liquid. The moment these supercooled drops hit any surface, they freeze instantly, creating a smooth coating of clear ice. This is what we're expecting tonight north and northwest of New York City. A winter weather advisory is in effect from 4 p.m. this afternoon through 2 a.m. Monday morning for interior Connecticut, the Hudson Valley, and northwest New Jersey. The forecast calls for up to 0.2 of an inch of ice accumulation in some areas, particularly the northern Hudson Valley. Let me explain why ice accumulation is so dangerous. When ice forms on roads, you can't see it. We call it black ice. The road looks wet, but it's actually a frictionless surface. Your tires have almost no grip. Even walking becomes treacherous. But it's the impacts on infrastructure that make ice storms truly devastating. Ice weighs approximately 57 pounds per cubic foot. When ice coats power lines and tree branches, the weight becomes enormous. A quarter-inch ice coating on a power line can add 500 pounds of weight between poles. Trees and branches snap, power lines come down, transformers explode. At 1/10 of an inch, you see isolated power outages. At 2/10, which is our forecast tonight, you get numerous outages. At a quarter-inch or more, you're looking at widespread catastrophic damage that can take weeks to repair. The thermodynamics involved are fascinating. For freezing rain to occur, you need a very specific temperature profile. At the surface, temperatures must be at or slightly below 32 degrees Fahrenheit. Between the surface and about 3,000 feet, the air is below freezing, but between 3,000 and 8,000 feet, there's a layer warmer than 32 degrees. Above 8,000 feet, it's below freezing again where clouds form. Weather balloons launched twice daily give us this temperature profile. Meteorologists look at something called a sounding, which is a vertical profile of temperature, humidity, and wind. When the sounding shows that inverted layer, the warm air sandwiched between cold layers, forecasters issue freezing rain warnings. The thickness of each layer determines whether you get snow, sleet, or freezing rain. Tonight's setup shows temperatures at the surface, hovering right around 32 degrees in the advisory area. That's the critical threshold, north and west of the city, where elevations are slightly higher and urban heat is absent. Temperatures drop to 30, 31 degrees. That's cold enough for freezing rain. In the city itself and along the coast, temperatures stay at 34, 35 degrees. That's just warm enough for plain rain. Let me teach you how to observe weather conditions yourself and make your own predictions. This is knowledge people had before modern technology, and it's still valuable today. First, watch the clouds. Clouds tell you what's happening in the atmosphere. High clouds, cirrus clouds, thin and wispy, indicate moisture at high altitude, typically above 20,000 feet. When you see cirrus clouds thickening and lowering, bad weather is usually 12 to 24 hours away. Mid-level clouds, altostratus and altocumulus, occur between 6,000 and 20,000 feet. These often precede a storm by 6 to 12 hours. Low clouds, stratus, stratocumulus, and nimbostratus, bring the actual precipitation. Watch the wind. Wind direction tells you what air mass you're in. In winter, north and northwest winds bring cold Canadian air. South and southwest winds bring warm Gulf air. East and northeast winds often precede coastal storms. When wind shifts suddenly, particularly from south to west or northwest, a cold front has passed. Watch the barometric pressure. If you have a barometer, and I recommend every weather enthusiast own one, watch for pressure changes. Falling pressure indicates approaching low pressure and bad weather. Rising pressure indicates improving conditions. The rate of change matters more than the absolute value. Rapidly falling pressure means a strong storm is approaching. Now, let's talk about what's happening right now across different regions, because each area faces unique challenges. In the upper Midwest, blizzard warnings are in effect. A blizzard requires sustained winds of 35 miles per hour or more, visibility reduced to a quarter mile or less by falling or blowing snow, and these conditions persisting for at least 3 hours. Wind is the defining characteristic of a blizzard. You can have a blizzard with relatively modest snowfall if winds are strong enough to blow existing snow. Conversely, you can have heavy snow without a blizzard if winds are calm. Today, we're getting both heavy snow and extreme winds. That's a particularly dangerous combination. Current wind gusts across Nebraska, Kansas, and South Dakota are already at 40+ miles per hour. By this afternoon, Albert Lea, Minnesota expects 60 to 70 mile per hour winds. Madison and Green Bay, Wisconsin, 50 to 60. Chicago, 50 to 60. These winds are approaching hurricane force. Combined with falling snow, visibility will drop to 0 at times. The snow itself is being enhanced by the Great Lakes. Lake effect snow is one of nature's most impressive weather phenomena. Here's how it works in detail. Cold air flowing from Canada has temperatures in the teens. The Great Lakes, particularly Lake Michigan and Lake Superior, have surface temperatures in the mid to upper 30s. That's a temperature difference of 20 degrees or more. When air moves across water, that's much warmer than the air itself. Heat and moisture transfer from the water to the air. This makes the air unstable. Warm, moist air rises rapidly. As it rises, it cools. Water vapor condenses. Clouds form in narrow bands aligned with the wind direction. On the downwind shore, these clouds hit land and rise further, producing intense snowfall. The ingredients that maximize lake effect snow are a large temperature difference between lake and air, a long fetch meaning wind blows over many miles of open water, and wind direction perpendicular to the lake's long axis. Right now, all three factors are maximized for western Michigan. The Upper Peninsula is already measuring snow in feet. Later, when winds shift more westerly, western New York gets hammered. Buffalo and areas south could see 2 to 4 feet of snow from lake effect alone over the next several days. For Chicago, the storm timeline is critical. Right now, conditions are deteriorating. This afternoon brings heavy snow and rapidly increasing winds. By tonight, full blizzard conditions. Travel becomes impossible. Even experienced winter drivers can't handle whiteout conditions. If you're in Chicago or anywhere in the storm's path, the window to prepare is closing. Get home, stay home. Cleveland follows a similar timeline but a few hours behind. This evening brings the worst conditions. Northeast Ohio will deal with lake effect snow enhancement off Lake Erie on the backside of the system Monday and potentially into Tuesday. The snowbelt south and east of Cleveland, that's where the biggest totals accumulate. For the I-95 corridor, the story is different. Philadelphia, New York, Boston, you're getting rain. That might sound less dangerous than snow and ice, but rain brings its own hazards. Heavy rain at cold temperatures means reduced visibility, slick roads, and hydroplaning potential. Airports already struggling with backlogs from previous disruptions face more delays. Over 9,000 flights have been canceled or delayed since Friday. That number will grow. Major New York area airports, JFK, LaGuardia, and Newark, issued snow warnings Friday and are now dealing with rain impacts. American Airlines, United, and JetBlue waived change fees for affected travelers. If you're trying to fly in the next 48 hours, expect disruptions. Check your flight status obsessively. Have backup plans. On the West Coast, an entirely different but equally dangerous situation continues. California is being hit by atmospheric rivers, and the impacts have been catastrophic. Christmas Eve and Christmas Day, storms dropped 11 inches of rain in parts of Los Angeles County. At least 3 people died. Flash floods swept through communities. Mudslides buried homes. About 100,000 people lost power. An atmospheric river is a concentrated stream of moisture in the atmosphere, typically a few hundred miles wide but more than 1,000 miles long. These features transport enormous amounts of water vapor from tropical regions toward the poles. When an atmospheric river encounters mountains and is forced to rise, the moisture condenses rapidly, producing extreme rainfall rates. California's geography makes it particularly vulnerable. When atmospheric rivers approach from the southwest, they hit the coast ranges first, producing heavy rain. Then they encounter the Sierra Nevada, producing even heavier rain and snow at higher elevations. The steep terrain causes rapid runoff. Rivers rise quickly. Flooding occurs in valleys downstream. But the situation is worse in burn-scar areas. The Thomas Fire, the Woolsey Fire, the Palisades Fire, these and other recent wildfires have left hillsides bare. When fire burns vegetation, it does more than just remove plants. The intense heat chemically alters the soil, creating a water-repellent layer. Normal soil absorbs rain like a sponge. Fire-affected soil repels water. When atmospheric rivers dump inches of rain per hour onto fire-scarred slopes, the water doesn't soak in. It runs off immediately, carrying loose soil, ash, rocks, and debris. The result is debris flows, fast-moving walls of mud and rubble that can reach speeds of 30 miles per hour. These flows have tremendous destructive power. They can sweep away vehicles, destroy homes, and bury entire neighborhoods in minutes. Los Angeles County officials ordered evacuations for about 380 households in burn-scar areas. Some residents hesitated, not understanding the danger. One man described waking to 2 feet of water in his apartment. Another hiked through the storm to rescue cats from his grandfather's flooded home. These stories illustrate both the danger and the human spirit of helping others. More atmospheric rivers are forecast to impact California this week. Each one brings renewed flooding potential. The soil is already saturated. Rivers are high. Any additional rain will produce immediate runoff. This is a dangerous pattern that shows no signs of breaking. Governor Gavin Newsom declared a state of emergency. The National Weather Service issued flash flood warnings. Officials urged people to avoid travel and heed evacuation orders. In disasters, there's often a tension between protecting property and protecting life. People want to stay and save their homes, but homes can be rebuilt. Lives cannot be recovered. In Matthew chapter 6, verse 25, Jesus asks, "Is not life more than food, and the body more than clothing?" The principle applies here. Is your home worth more than your life? When officials order evacuations, they're based on real danger assessments. Taking those orders seriously is wisdom, not weakness. Now, let me teach you about cold weather physiology. Because understanding how your body responds to cold can save your life. The human body works hard to maintain a core temperature of about 98.6 degrees Fahrenheit. When you're exposed to cold, your body has several defense mechanisms. First, vasoconstriction. Blood vessels in your extremities, hands, feet, ears, nose, constrict to reduce blood flow to those areas. This preserves heat for your core and vital organs. That's why your fingers and toes get cold first. Second, shivering. This involuntary muscle movement generates heat through metabolic activity. Shivering can increase heat production by up to 5 times. Third, increased metabolism. Your body burns more calories to generate heat. But these mechanisms have limits. When you can't generate heat fast enough to match heat loss, hypothermia develops. Hypothermia is defined as a core body temperature below 95 degrees. It progresses through stages. Mild hypothermia, 90 to 95 degrees, causes shivering, confusion, impaired judgment, and loss of fine motor skills. Your decision-making ability deteriorates. You might not realize you're in danger. This is when people make fatal mistakes like removing clothing or wandering away from shelter. Moderate hypothermia, 82 to 90 degrees, brings violent shivering that suddenly stops. This is a bad sign, not a good one. It means your body is shutting down. Confusion becomes severe, speech slurs, muscles stiffen, coordination fails, the person may appear drunk. Severe hypothermia, below 82 degrees, is a medical emergency. Shivering stops completely. Unconsciousness develops, breathing slows, heart rate drops. Without immediate medical intervention, death follows. Prevention is critical. Dress in layers. The layer system works because air trapped between layers provides insulation. Your base layer should wick moisture away from skin. Cotton kills in winter because it holds moisture. Use synthetic or wool materials. The middle layer provides insulation. Fleece, down, or synthetic insulation work well. The outer layer blocks wind and moisture. A good winter coat is an investment in your safety. Cover your extremities. Heat loss from your head is significant because blood vessels in your scalp don't constrict as much as in your hands and feet. Wear a hat. Cover your ears. Use a scarf to protect your face and neck. Wear insulated gloves or mittens. Mittens are warmer because they keep fingers together, but gloves allow better dexterity. Have both available. Recognize frostbite warning signs. Frostbite is freezing of tissue, most commonly fingers, toes, nose, and ears. Early warning signs include numbness, tingling, and skin that looks pale or white. As frostbite progresses, skin becomes hard and waxy. Blisters may form. In severe cases, tissue dies and turns black. This requires amputation. Frostbite can occur in as little as 5 to 10 minutes when temperatures are below zero and wind chills are extreme. Wind chill describes how cold it feels when wind is blowing. Wind doesn't actually lower temperature, but it removes the thin layer of warm air around your skin, accelerating heat loss. A wind chill of -30 degrees means exposed skin will freeze in about 10 minutes. If you suspect frostbite, get indoors immediately. Remove any wet clothing. Warm the affected area gradually using body heat or lukewarm water, never hot water. Don't rub frostbitten skin, as this causes more damage. Don't use direct heat like a heating pad or fire. Seek medical attention, especially for moderate to severe frostbite. Staying hydrated is often overlooked in winter. You lose moisture through breathing, especially in cold, dry air. You may not feel thirsty because cold suppresses thirst sensation. But dehydration impairs your body's ability to generate heat and makes you more susceptible to cold injuries. Drink water regularly, even if you don't feel thirsty. Nutrition matters too. Your body burns more calories in cold weather. Eat regular meals with adequate calories and protein. High-energy snacks like nuts, trail mix, and energy bars provide quick fuel for heat production. Let me discuss extended forecasting and pattern prediction, because understanding what's coming helps you plan. Weather forecasts are reliable out to about 7 days. Beyond that, uncertainty increases significantly, but we can identify patterns and trends that give us a general sense of what to expect. The current pattern, the split-flow jet stream, tends to be persistent. Once established, these configurations often last 2 to 3 weeks or longer. The physics behind this involves something called blocking patterns. High-pressure systems can become stationary and block the normal west-to-east progression of weather systems. This forces the jet stream to flow around them, creating persistent patterns. Right now, we have high pressure over the North Atlantic and another high over the Eastern Pacific. These blocking highs are steering the jet stream into its current split-flow configuration. Until these blocks break down, the pattern continues. Computer models suggest this configuration persists through at least the first 10 days of January. What does that mean practically? More storm systems will track along similar paths. The Great Lakes and Northeast can expect additional snow and ice events. California faces more atmospheric river storms. Temperatures remain below normal for most of the eastern United States. This doesn't mean every day is stormy, but it means the pattern favors active weather. For specific locations, here's what to watch. Chicago and the Midwest should prepare for additional winter storms and prolonged cold. Lake effect snow continues affecting traditional snowbelt areas. New York and the Northeast face ongoing threats of winter precipitation, with the risk of rain, snow, or ice, depending on each system's exact track. California needs to remain alert for additional flooding, especially in burn scar areas where soil saturation is extreme. Planning around these patterns is wise. If you need to travel, build in flexibility. Check forecasts frequently. Have backup plans. If you have vulnerable family members, check on them regularly. If you have medical appointments or other essential travel, consider rescheduling if weather threatens. But don't let weather forecasts create anxiety. In Philippians chapter 4, verses 6 and 7, Paul writes, "Do not be anxious about anything, but in every situation, by prayer and petition, with thanksgiving, present your requests to God, and the peace of God, which transcends all understanding, will guard your hearts and your minds in Christ Jesus." Weather is uncertain, life is uncertain, but we can have peace even in uncertainty. Preparation and faith aren't opposites, they work together. We prepare because we're wise and capable. We trust because we know ultimately we're not in control, and that's okay. The God who created weather systems understands them perfectly. He's not surprised by any of this. Let me summarize the critical information from this 30-minute education. Multiple winter storms stem from a split-flow jet stream pattern, creating two active storm tracks. Eastern storms bring blizzard conditions to the Midwest with 50 to 70 mile-per-hour winds, dangerous cold, and heavy lake-effect snow. Tonight, freezing rain threatens areas north of New York City with up to 0.2 of an inch ice accumulation. California's atmospheric river pattern continues, with extreme flooding in burn scar areas and additional storms approaching. Understand precipitation types and how they form. Know that snow forms in all cold air, sleet forms with refreezing, and freezing rain forms with supercooled drops. Recognize that ice accumulation of 0.2 of an inch causes widespread power outages. Learn to read weather signs through cloud observation, wind direction, and pressure changes. Protect yourself from cold through proper layering, covering extremities, recognizing hypothermia and frostbite symptoms, staying hydrated, and eating adequate calories. Know winter driving techniques including reducing speed, increasing following distance, avoiding sudden movements, and knowing when to get off the road. The pattern persists for weeks ahead. Stay informed, check forecasts daily. Have emergency supplies ready, help your neighbors, exercise wisdom in all decisions. May God grant you safety, wisdom, and peace through these weather challenges.